Hello and welcome to the Sleepy Scholar. I'm so glad you're here. Maybe you're wrapped in blankets, maybe you're curled up on the couch, or maybe you're just drifting through the last moments of your day. Wherever you are, this is your quiet corner of the night, where science turns into story and the universe feels just a little closer. Tonight, we're diving into one of the boldest, strangest questions ever asked. What if our entire universe, everything you know, every star you've ever seen, even the space and time around you, was born inside a black hole? It sounds like the plot twist of a sci-fi epic, but it's an idea that some scientists take very seriously. Don't worry, this isn't a late-night physics lecture. Think of it more like a dream where galaxies spill from shadows and black holes turn out to be cosmic wombs. All you need to do is listen and wonder. And hey, if this journey into the deep unknown keeps you awake, at least you'll have one of the universe's strangest bedtime stories to think about. Before we begin, if you enjoy these calm explorations, it would mean the world if you tapped the like button, subscribed, or shared in the comments where you're watching from and maybe what stars look like above your corner of the universe. All right, take a breath, let the day fade, and let's step across the horizon into the question of whether we live inside a black hole. Gravity. It's the reason your coffee doesn't float off the table, the reason you don't drift away mid-yawn, and the reason that apple smacked Isaac Newton on the head instead of floating politely past him. It's the most loyal companion you've ever had, even if you barely notice it most of the time. Think about it. Gravity has been hugging you since the moment you were born, pulling you close to Earth like an invisible safety harness you never asked for but can't take off. It's dependable, unwavering, and sometimes a little clingy. Without it, you'd be in constant chaos. Your cereal spoon levitating away, your shampoo drifting across the bathroom, and your socks never staying where you left them. But here's the wild part. This invisible force doesn't just keep you from doing an accidental spacewalk in your bedroom. It choreographs the movements of oceans, planets, and galaxies. It's like the universe's secret DJ, spinning a cosmic playlist that everything from your body to black holes has to dance to. You may think of gravity as ordinary, but if you zoom out far enough, it's absolutely extraordinary. Start with something small, your body, for example. Right now, as you sit or lie wherever you are, Earth is pulling you down with just enough force to keep you rooted. The pressure you feel on your mattress or chair, that's gravity at work. And although it feels steady, this force is a delicate balance. If Earth's pull were a tiny bit stronger, walking would feel like carrying a backpack filled with bowling balls. If it were weaker, you'd bounce around like you were on a trampoline every time you sneezed. In other words, the pull we live with is strangely perfect, giving us the stability to build cities, bake bread, and yes, complain about the weather. This same invisible hand also runs the grand performance of the seas. Every time you watch waves roll in or tides shift along the shore, you're seeing gravity in action. The moon, modest and distant, is like a DJ with a long arm reaching across space, tugging on Earth's oceans. It doesn't lift the whole ocean in one go, that would be absurd. But it stretches it, creating bulges of water that slide around the planet. Twice a day, the sea rises and falls in sync with this cosmic tug of war. And the sun, never one to be left out, joins in too, adding its own gravitational rhythm. The result? The living pulse of our oceans, the breath of our planet, powered by celestial pull. Of course, humans, being humans, we didn't figure this out right away. Ancient people had myths for everything. Some thought sea gods were sloshing water around with divine ladles. Others imagined giant creatures beneath the waves shifting in their sleep. Then Newton came along, got hit with his apple, and declared, "Hey, Maybe there's one invisible force that explains both falling apples and the rhythm of the oceans, and the universe collectively facepalmed like, finally! Took you long enough. Gravity, however, is not just a one-trick pony pulling apples and waves. It's the glue that keeps the solar system intact. Imagine our planets as distracted kids at a playground. Without gravity, Earth would speed straight past the sun like it was late for an appointment and never look back. Mercury, Venus, Mars, all of them would scatter into the void, drifting endlessly with no group project to keep them together. But gravity keeps them in orbit, pulling them into an endless dance around the sun. It's not a leash so much as a perfect balance. Forward motion tugged back just enough to curve into circles and ellipses. And this balance is what allows seasons, climates, and life itself to exist. Now, let's take a pause and ask a question. What even is gravity? You feel it every day, but you can't see it, smell it, or taste it. The way physicists describe it is that gravity is the warping of space and time by anything that has mass. Picture your mattress again. If you drop a bowling ball in the middle, the mattress dips and smaller objects roll toward the heavier one. That dip is a two-dimensional analogy for what's happening in 3 dimensions with planets and stars. Mass bends the fabric of reality, and everything nearby feels the pull. Einstein took this idea and gave it style. In his theory of general relativity, space is not just an empty backdrop. It's more like a flexible stage that responds to the actors upon it. The Earth isn't circling the sun because the sun is lassoing it with an invisible rope. Instead, the sun warps space around it, and Earth simply follows the curve. You're not being pulled down by Earth when you fall. You're sliding along the curves of space-time toward the planet's center. It's less of a magical hand dragging you and more of a cosmic geometry lesson. This is where gravity starts to get cinematic. Imagine space not as nothingness, but like a stretchy sheet. Stars are bowling balls, black holes are cannonballs, and you're a marble rolling along the dips and curves. Sometimes the path is smooth, like Earth orbiting the sun. Other times the dip is so steep that not even light can escape. That's when you get a black hole, the diva of gravity. But let's not get ahead of ourselves. For now, stay focused on this. Every step you take, every time your keys fall between the couch cushions, you're interacting with the same law that keeps galaxies from flying apart. Let's bring it closer to home with an experiment you can try. Stand up, unless you're already lying comfortably, in which case, stay cozy and use your imagination. Now jump. You'll go up, and then you'll come back down. Why? Because Earth is huge. Not just kinda huge, but overwhelming, eat a million huge pizzas and still not be enough huge. Its mass gives it a gravitational pull so strong that your little leg muscles don't stand a chance of escaping it. To break free from Earth's grip entirely, you'd need to reach what's called escape velocity, about 11 kilometers per second, or roughly 25,000 miles per hour. That's faster than most cars, planes, and cheetahs combined. Unless you've secretly been hiding a rocket pack under your bed, you're not going anywhere. What's fascinating, though, is that gravity is both weak and strong. On a human scale, it feels relentless. You can't fight it without machines or clever tricks. But compared to other fundamental forces, like electromagnetism, it's a pushover. A tiny refrigerator magnet can hold up a paperclip against the pole of the entire Earth. Think about that. One little magnet versus a whole planet, and the magnet wins. Gravity loses, looking embarrassed in the corner. Yet on the cosmic scale, gravity reigns supreme, shaping stars, galaxies, and clusters into colossal structures. Weak in your kitchen, unstoppable across billions of light years. Now here's a fun twist. Gravity never really turns off. Its reach is infinite. If you drop your phone on the floor, yes, Earth's gravity is the main culprit, but technically that phone is also being pulled toward the sun, the moon, and even distant galaxies. The force just gets weaker with distance, like a voice fading down a hallway. The Andromeda galaxy, sitting 2.5 million light-years away, is tugging on you right now. You don't notice it because Earth's gravity completely overshadows it, but the pull is there. In fact, the entire Milky Way is in a slow-motion gravitational waltz with Andromeda. And billions of years from now, the two galaxies will collide, all because of gravity's patience. It doesn't rush, it just waits. Gravity also shapes time itself. Near massive objects, clocks run slower. That's not a poetic exaggeration, it's measurable. Astronauts orbiting Earth experience time ever so slightly differently than you do on the ground. GPS satellites even have to account for this time dilation to stay accurate, or else your navigation system would be sending you into cornfields instead of coffee shops. Gravity isn't just about falling, it's about bending reality at its seams. So where does this leave us tonight, as you lie there listening? It leaves us in the middle of a universe connected by an unseen web. Every movement you make, every step you take, is part of this grand choreography. When you drop something, when you watch the moon rise, when you marvel at the planets aligned in the night sky, it's all the same story, the same pull, the same rule book. And yet, for all its familiarity, gravity still hides secrets. We don't fully understand why it has the strength that it does, or how it fits neatly with the other forces of nature. Is it woven from the threads of tiny particles? Does it whisper through hidden dimensions? Physicists are still scratching their heads, poking equations, and trying to make sense of this force that runs everything. It's like having the most important character in a movie, but never knowing their backstory. That's where our journey heads next. Imagine falling into a hole so extreme that not even light, the fastest traveler in the universe, can get back out. That's a black hole for you. Cosmic Houdinis of the universe, swallowing everything and never giving back a receipt. And yet, despite their terrifying reputation, they're not monsters lurking out there ready to pounce. They're natural consequences of stars living out their dramatic, fiery lives. You could say black holes are less like villains and more like the over-the-top drama queens of the cosmos. When they collapse, they make sure everyone notices. So how does one of these strange creatures even come into being? Let's start with a star. Not just any star, but a massive one, far bigger than our sun. For millions of years, this star has been a nuclear powerhouse, fusing hydrogen into helium, helium into heavier elements, balancing two forces, the outward push of radiation and the inward pull of gravity. Think of it like a tug-of-war that ends in a tie. The star stays stable, shining, keeping planets warm and looking good in telescopes. But when the star runs out of fuel, it's like pulling the batteries out of a flashlight. The outward push weakens, gravity stops playing nice, and suddenly the balance tips. Gravity wins. And when gravity wins, it doesn't do subtle. The star's core collapses, the outer layers explode in a spectacular supernova, and what's left behind is a dense remnant. Sometimes it's a neutron star, a city-sized object so dense that a teaspoon would weigh as much as a mountain. But if the original star was truly gigantic, the collapse doesn't stop there. The core keeps shrinking, smaller and smaller, until the escape velocity, the speed needed to break free from its pull, becomes greater than the speed of light. At that point, boom, a black hole is born. Now, about that escape velocity idea. On Earth, you'd have to reach around 11 kilometers per second to break free from our planet's gravity. That's already rocket territory. But imagine stacking more and more mass into a smaller and smaller space. The more mass you pack in, the stronger the gravity gets, and the faster you'd have to go to escape. Eventually, the required speed surpasses 300,000 kilometers per second, the universal speed limit, the speed of light itself. Once that happens, no particle, no beam, no witty one-liner can make it out. The star's remnant has disappeared behind a boundary called the event horizon, the ultimate no-return zone. What happens if you fall past that boundary? Well, here's where things get weird. For an outside observer, time slows down as you approach the event horizon. Imagine watching your friend fall toward a black hole. To you, they appear to move slower and slower, fading like an old VHS tape on pause. From their perspective, though, they plunge forward normally, crossing the horizon without noticing a big flashing neon sign that says, "Congratulations, you're doomed." Inside, the laws of physics as we know them start throwing up their hands in confusion. And then there's the infamous concept called spaghettification. Sounds delicious, right? It's less pasta night and more horrifying Stretch Armstrong experience. The closer you get to a black hole, the stronger the difference in gravitational pull between your head and your feet. If you were falling feet first, your feet would be yanked faster than your head, stretching your body longer and thinner. Scientists gave this terrifying ordeal a name that belongs on an Italian menu, but don't be fooled. Spaghettification is a one-way ticket to becoming cosmic linguini. Still, black holes aren't just cosmic shredders. They're also surprisingly elegant. They hide behind an event horizon, so we can't see them directly, but we can detect their presence by what they do to their surroundings. Imagine a black hole with a snack problem. It pulls in nearby gas and dust, forming a swirling disk of matter that heats up and glows brilliantly before vanishing across the horizon. This glowing disk can outshine entire galaxies, a kind of farewell fireworks display before the material disappears forever. And when black holes collide, they shake the fabric of space itself, sending ripples called gravitational waves across the universe, waves we can now detect on Earth, confirming Einstein's predictions and giving us a new way to listen to the cosmos. One of the most mesmerizing things about black holes is how they bend light. Because of their extreme warping of space, they act like funhouse mirrors, distorting the view of stars and galaxies behind them. In fact, this is how we got our first picture of a black hole, the famous blurry orange donut captured in 1919. What we actually saw wasn't the black hole itself, but the glowing ring of hot matter circling the event horizon, twisted into that eerie, beautiful halo by the black hole's warping of space-time. It was like finally catching a shadow of something we'd only dreamed about for decades. And here's the kicker. Black holes might not even be the end of the story. Some physicists speculate that what we call a black hole could actually be a kind of doorway. What's on the other side? Another universe? A strange hidden realm? A cosmic recycling bin where old matter gets repurposed? We don't know. That uncertainty is part of the allure. Black holes are like the universe's best cliffhangers. Just when you think you understand, they leave you dangling with more questions than answers. Think about it for a second. Right now, as you listen, there are black holes scattered across our galaxy. Some are the remnants of ancient stars, quietly existing, invisible unless they interact with nearby matter. Others are gargantuan beasts, millions or even billions of times the mass of our Sun, lurking at the centers of galaxies, shaping their growth. The very Milky Way has one at its core, Sagittarius A star, a supermassive black hole sitting there like the boss level in a cosmic video game. Without it, our galaxy wouldn't look the way it does. Without black holes, the universe itself might be unrecognizable. The irony is, for all their power, black holes are also vanishing. Stephen Hawking showed us that they can leak radiation, Hawking radiation, causing them to slowly evaporate over unimaginable stretches of time. Yes, black holes eventually fade away, like embers cooling after a fire. It won't happen anytime soon. A typical black hole takes longer to evaporate than the current age of the universe. But still, even these titans are not immortal. So as you picture yourself tumbling into the dark, remember this. Falling into a black hole is less like hitting a wall and more like stepping into a mystery. Beyond the event horizon, the rules change, and we don't know how. Are they cosmic endpoints or cosmic beginnings? Are they death traps or birthplaces? Maybe both. Black holes remind us that the universe isn't finished with its surprises. And that's exactly where we're heading next. Because if falling into a black hole stretches your body and bends your sense of time, what happens at the edge itself, that thin dividing line between escape and no escape? The event horizon is calling, and it's time to step closer. Picture standing at the edge of the strangest beach imaginable. No sand between your toes, no sunscreen required, but still a shoreline of sorts. This isn't a shoreline made of water. It's the event horizon, the border around a black hole, the ultimate point of no return. Cross it, and you're gone. Stay outside it, and you can still tell the story. It's like watching the world's most dangerous swimming pool and thinking, sure, I'll dip a toe, while knowing that the lifeguard whistle won't help you on the other side. So what actually happens here at this bizarre boundary? Let's rewind a little. Imagine space-time as a giant fabric. This is one of those metaphors you've probably heard before, but stick with it because it works. Heavy objects like stars press down on this fabric, making curves and dimples. Planets roll along those curves, orbiting happily, like marbles spinning around on a trampoline. Now replace that star with something so heavy, so compressed that it doesn't just make a dent in the trampoline, it rips straight through. That's what a black hole does to the fabric of space and time. And the event horizon? That's the circular edge around the tear, the place where the slope becomes so steep that nothing, not light, not Netflix signals, not even a desperate email can get back out. Standing here, the rules of physics already feel distorted. From far away, you might think someone falling toward the horizon is slowing down, as if a cosmic remote control hit pause. Light from their body stretches into longer, redder wavelengths. They fade and fade until they seem frozen on the brink. But to the poor traveler doing the actual falling, nothing feels odd as they cross the horizon. No sudden flash, no "you are now entering the danger zone" sign. Just a calm slide forward, unaware that they've stepped into a part of reality where the word return doesn't exist anymore. It's the ultimate case of perspective mismatch. The outside world thinks you've stopped, you think you're still moving. Both are right, depending on who's watching. This strange duality makes the event horizon one of the most poetic places in the cosmos. It's the universe's way of saying, two truths can exist at once, and you'll have to deal with it. It's also a reminder that our everyday sense of time is laughably local. We treat seconds and minutes like fixed ticks of a clock, but here they stretch and bend like taffy under gravity's influence. Your minute is not the same as someone else's minute near a black hole. Try using that excuse next time you're late. Sorry, I was experiencing gravitational time dilation. It probably won't get you out of a meeting, but technically, Einstein would back you up. Let's zoom in further. The horizon itself isn't a physical wall. You wouldn't smack into it like hitting glass. It's more like an invisible border in space, a threshold that divides "maybe there's hope" from "nope, not a chance." Imagine a waterfall. Fish swimming above the falls can still turn around, but cross the edge and the current is too strong. You're going over. The horizon is that lip, only instead of water pulling you down, it's the relentless curve of space-time. Everything is dragged inward. You don't have a choice. And unlike the waterfall, you can't even see the plunge from the inside, because once you're past the edge, all paths lead inward. Even light has no escape route. Now, here's where the mind-bending questions roll in. If you hover just outside the horizon, you'll see matter swirling around it, glowing hot from friction as it spirals in. Astronomers call it the accretion disk, but I prefer to think of it as the black hole's dinner plate. It's the last light show you'll get before the main course disappears forever. To telescopes, this glowing whirlpool reveals the location of something that otherwise hides in total darkness. That's how we got the famous image of the black hole in the galaxy M87, the orange ring lit up by doomed gas encircling a darkness no one can penetrate. That glowing edge wasn't just pretty, it was history. For the first time, we actually saw the shadow of an event horizon, the closest thing to a photograph of nothing humanity has ever taken. What's wild is that the horizon doesn't just define a place in space, it defines a boundary in knowledge. Everything beyond it is hidden forever. It's like the universe put up a no spoilers rule for what happens inside. And yet this curtain of mystery fuels entire careers in physics. Scientists debate what happens to information, every particle, every pattern that crosses the line. Does it vanish? Is it somehow stored on the horizon itself, like cosmic graffiti etched onto the surface? This puzzle is known as the information paradox, and it's kept people like Stephen Hawking and countless others arguing for decades. Imagine misplacing your house keys, but instead of worrying about being late, you're worried about the entire foundation of reality. That's the scale of this mystery. But the horizon isn't just about death and endings. Some theories suggest it might be a bridge, a boundary that connects not to nothingness, but to something else entirely. Wormholes, white holes, alternate universes. Take your pick. The equations don't rule them out completely. It's like the event horizon might be less of a stop sign and more like a hidden door. We don't know what's on the other side. Maybe nothing. Maybe everything. Maybe the cosmic equivalent of a prank. The uncertainty makes it the ultimate cliffhanger, written into the fabric of physics itself. And here's a thought experiment for you. Imagine you could shrink yourself down to the size of an atom and surf the edge of the event horizon. From your vantage point, space would warp in surreal ways. Light from distant stars would bend around the black hole, wrapping into halos and arcs. You'd see distorted images of the universe behind you, twisted into funhouse shapes. The horizon would glow with the heat of infalling matter, while the core of the black hole, whatever it is, would remain hidden, unknowable, just out of sight. It would be terrifying, yes, but also breathtaking, the kind of view that makes you wonder whether fear and awe are just two sides of the same coin. It's tempting to think of the event horizon as an end, the last page in a book you're not allowed to read past. But maybe it's better to think of it as a mirror. It reflects back to us our own curiosity, our drive to understand, and our acceptance that some mysteries aren't solved easily. After all, the very fact that humans on a small blue planet can even imagine what's happening here is astonishing. With telescopes, mathematics, and stubborn imagination, we've managed to sketch the outline of the most unreachable places in the universe. The event horizon isn't just an edge for matter, it's also an edge for human knowledge, and standing at the edge is where discovery always begins. So here we are, gazing inward at the ultimate frontier, the shoreline where space and time collapse into something new. We're not crossing just yet, but we can feel the pull, hear the questions it whispers, see the light bending and fading. And the real intrigue is not only what lies beyond the edge, but what happens as time itself slows, distorts, and unravels at the border. Because if the horizon is strange, then the river of time flowing toward it is even stranger, and that's exactly where our story drifts next. Imagine you're standing in line at your favorite coffee shop. The person in front of you orders something so complicated it sounds like a Shakespearean soliloquy. Oat milk, half calf, extra hot, double foam. caramel drizzle in the shape of a Fibonacci spiral. The barista stares, time stretches, and suddenly those 30 seconds feel like an eternity. That's kind of what time does near a black hole, except instead of a barista and bad latte poetry, it's the very fabric of the universe slowing you down. Welcome to the river of time, where seconds don't march neatly forward, but twist, stretch, and crawl like syrup poured from a spoon. Time, as we like to imagine it, feels sturdy. You wake up, brush your teeth, scroll through memes, and the clock ticks on in an orderly fashion. But here's the catch. That orderly fashion is only true in your local neighborhood. Einstein showed us that time is a diva. It changes its rhythm depending on who's watching and how strong gravity is pulling. In everyday life, we don't notice. Your living room clock and your kitchen clock don't disagree by more than a nanosecond, unless maybe one sits next to a black hole disguised as a microwave. But out here, near a black hole's horizon, the difference isn't subtle, it's cosmic. Picture a friend hovering safely far away with their stopwatch. From their perspective, you're the slowest creature alive. Each step you take toward the horizon looks dragged out, like you're moving through molasses. Your hand raises, your wave lingers, and your face seems to freeze mid-expression. The closer you drift, the more your time stretches out until, poof, you appear stuck, forever waving. From their vantage point, you never actually cross the line. It's like the world's most awkward zoom lag, only the lag is caused by gravity itself. But from your perspective, totally different story. To you, time feels normal. Your watch ticks, your heart beats, your thoughts zip along. Nothing in your inner timeline says, hey, you're moving slower. This is the bizarre magic of relativity. Both realities are true. You are fine. Your friend insists you're stuck. The universe nods and says, yep, both of you are right. Deal with it. It gets weirder when you realize time doesn't just slow near a black hole, it warps everywhere. Even here on Earth, your feet age a smidge slower than your head, because gravity is stronger closer to the ground. You are literally older by milliseconds when you're standing tall compared to lying flat. Think about that. Next time someone teases you about slouching, you can smugly say, I'm preserving my youth. Astronauts on the International Space Station also experience a slightly different clock speed. GPS satellites, zooming high above Earth, tick faster than clocks on the ground, and engineers must correct for this daily. If they didn't, your map app would tell you to turn left into a lake. Near a black hole, though, this isn't a matter of milliseconds, it's dramatic. If you were brave or foolish enough to hover close to the event horizon, a few hours for you might equal thousands, even millions of years for someone watching from far away. Think of it as the ultimate power nap. You snooze for what feels like a weekend and wake up to find civilizations risen and fallen, languages evolved, and maybe pizza finally perfected. This isn't just science fiction. This is real, measurable physics. So why does gravity get to bully time like this? It comes down to space-time itself. Einstein told us to stop thinking of space and time as separate. Instead, imagine a four-dimensional fabric where time is stitched right into the weave. Add mass, and the fabric bends. Add extreme mass, like a black hole, and it bends so steeply that even the flow of time gets caught in the whirlpool. The river of time slows, thickens, and near the horizon it almost seems to stop. Not because the universe forgets how to tick, but because gravity changes the pace of the ticking itself. Here's another way to picture it. Imagine a river flowing smoothly. Upstream, it's calm, steady, predictable, but downstream, as the water nears a waterfall, it stretches, eddies, slows in some places, rushes in others. If you're standing far from the edge, the flow seems steady. But if you're clinging to the edge of the drop, your experience is utterly different. Black holes are cosmic waterfalls,
and time is the river. Dip your toes in near the horizon, and suddenly your seconds don't match the rest of the universe's ticking. There's something both terrifying and beautiful about this. Terrifying because it means you could, in theory, fall into a black hole and experience only moments while the rest of the cosmos moves on without you. Beautiful because it shows that time is not the rigid metronome we once thought it was. It's flexible, elastic, personal. Your heartbeat and your wristwatch are local experiences, little campfires of time keeping you warm in your own frame of reference. Step too close to gravity's pull, and those fires dim compared to the universe's raging bonfire. This bending of time has slipped into popular culture, of course. Movies love it. In Interstellar, astronauts visit a planet orbiting close to a black hole, and every hour they spend there equals 7 years for their colleagues waiting elsewhere. That wasn't just Hollywood drama. It was rooted in real physics. Sure, the script polished it for emotional punch, but the core idea holds. A black hole could turn your afternoon stroll into someone else's future history lesson. And here's the kicker. The slowing of time near black holes might also hold the key to some of physics's deepest puzzles. If time stretches and bends, what happens at the ultimate limit, inside the horizon? Does time stop completely? Does it even mean to talk about time once you've crossed that threshold? Maybe time, as we know it, dissolves, replaced by some deeper layer of reality we don't yet understand. It's like peeling an onion and realizing that beneath all the layers there isn't a center at all, just questions. There's also the emotional weight of this thought experiment. Imagine watching a loved one fall toward a black hole. To you, they appear frozen at the edge, light stretched into red until they fade away. To them, they've moved on, crossed over, experienced whatever comes next. Two truths forever separated by the bend of time. It's heartbreak written into the laws of physics. The river of time doesn't flow the same for everyone, and sometimes it carves gulfs that can't be crossed. But let's not end on despair. Instead, think about what this teaches us here, in our everyday lives. If time is flexible, relative, not some universal drumbeat, then every tick of your clock is precious in a whole new way. Your seconds are yours alone, stitched uniquely into your place in the cosmos. It makes our little moments, coffee with a friend, a late-night laugh, even the frustration of that endless coffee line, all the more extraordinary. Because while we may not be dancing near a black hole, we are still floating on this river of time, carried along by the currents of gravity and motion. And just like any river, this one doesn't just slow and stretch, it can also twist back on itself in ways we're only beginning to imagine. Some theories suggest time isn't just a one-way flow toward the future. Maybe there are eddies, loops, shortcuts hidden in the currents. Maybe black holes, with their warped clocks and twisted space, aren't just slowing us down, but pointing toward deeper truths about how time really works. If the horizon showed us the edge of space, then the river of time is about to show us the edge of causality itself. And that's where our story wades next. Have you ever stood between two mirrors and caught that endless tunnel of reflections? You see yourself repeated again and again, smaller and smaller, fading into infinity. It's hypnotic and a little unsettling, like your face just signed up for an infinite marathon without asking you. Now imagine that same idea stretched out across the cosmos. Not mirrors bouncing your haircut back and forth, but the very shape of reality reflecting itself in ways so bizarre it makes your bathroom trick look like child's play. That's where black holes step in, because they're not just cosmic vacuum cleaners hoovering up stars. They might also be mirrors of the universe itself. Think of it this way. When we look at a black hole, we see a boundary, the event horizon. To us, it's the ultimate edge, a line that says, beyond here, information and light are off limits. But some physicists suggest that what happens inside might not be sealed away at all. It might be a distorted echo of what's outside. Like one of those nesting dolls your grandmother had, where you pop open one doll and find another and another, until you're convinced the last one has to contain either a secret key or some kind of cosmic joke. In this view, a black hole isn't just hiding something, it's showing us a miniature model of the universe itself. Let's make it less abstract. Imagine the universe as a soap bubble. It's expanding, stretching, floating, maybe even shimmering if you catch it in the right light. Now, inside a black hole, you could picture another bubble forming, growing with its own rules of space and time. That bubble could feel as big and limitless to someone inside as our universe feels to us. Which raises the deliciously strange question: what if our universe is just someone else's black hole? Picture some enormous parent cosmos, where stars collapse, black holes form, and inside one of them, bam, our Big Bang erupts, carving out a universe we mistake for everything. It's like cosmic inception. Universes inside universes, each one hidden inside the belly of the last. The math isn't just wild daydreaming. The equations of general relativity, the same ones Einstein scribbled down with that mustachioed genius grin, actually allow this kind of nesting. When a star collapses, its matter squeezes down under its own gravity. Outside, we see a black hole form. But inside, the collapse doesn't just vanish into nothingness. The equations suggest it could keep going, bouncing into something new, maybe even expanding into its own universe. From the outside, we see doom. From the inside, they see creation. One doorway, two stories. This is where mirrors sneak back into the story, because what happens outside a black hole and what happens inside might be two reflections of the same rules. The event horizon could be thought of as the glass, and on one side is our view, while on the other side is a whole new landscape following similar patterns. The structure of galaxies, the way matter clumps together, even the strange balance between chaos and order, it's like nature is humming the same tune whether you're watching the big universe or the hidden one inside. Physics is full of symmetries like this, and black holes might just be the ultimate symmetry trick. Outside and inside as two versions of the same infinite reflection. Of course, you might be wondering, if universes can sprout inside black holes, does that mean ours is spawning new baby universes every time one forms? If so, black holes are less like cosmic death traps and more like interdimensional maternity wards. A star collapses, astronomers sigh, and somewhere deep within, a new cosmos takes its first breath. Maybe those new universes inherit some traits from their parent, like cosmic genetics. A universe with laws that allow black holes creates more universes with similar laws. That means universes might evolve, not through natural selection of animals, but through natural selection of physics itself. Charles Darwin meets Albert Einstein at the edge of a black hole. The nesting doll metaphor gets even stranger when you flip it around. What if inside our universe, we're not the outermost layer? Maybe we're inside some greater cosmos's black hole. And that cosmos is inside an even bigger one, and on until you run out of dolls or patience. Infinity isn't something our brains are wired to process easily. We're great at grocery lists and parking meters, less so at endless layers of reality. But mirrors and dolls give us a way to peek at the idea without frying our neurons completely. And speaking of frying, think about the way black holes blur boundaries. Normally, we like clear lines, inside the room or outside the room, coffee is hot or cold, Wi-Fi works or it doesn't. But black holes laugh at that kind of clarity. The event horizon is a boundary that both is and isn't. From one perspective, it's a hard edge. From another, it's a smooth continuation. In that sense, black holes don't just mirror the universe. They mirror our own tendency to crave borders where nature offers none. The inside becomes the outside, the boundary becomes a bridge, and suddenly you're left realizing that opposites aren't so opposite after all. This might sound mystical, but it's grounded in physics. Hawking radiation, the faint glow predicted to leak from black holes, suggests information isn't really lost. That means the outside contains hints of the inside. The mirror isn't perfect, but it's there. Like listening to an echo in a canyon, it's distorted, faint, but undeniably connected to the voice that started it. If information can survive the plunge, then maybe what happens inside isn't gone at all. It's reflected, encrypted in the shimmering skin of the horizon. The universe, it seems, has a flair for drama. Now, here's a fun twist. If we are inside a black hole, that would explain why our universe seems to have an edge we can't reach. The cosmic horizon, the farthest we can see, is a kind of event horizon for us. We can't look beyond it, not because nothing exists there, but because light hasn't had time to reach us. In that sense, the universe and a black hole look suspiciously similar. Both have horizons, both hide interiors, both leave us staring at limits and wondering what lies past them. It's almost as if reality recycles its greatest hits in different scales, mirrors within mirrors. So what do we do with this? Well, it's less about proving we're in a cosmic nesting doll and more about appreciating the poetry baked into the laws of physics. Black holes, which once seemed like monsters in the dark, start to look like teachers instead. They show us that beginnings and endings blur, that destruction and creation are two sides of one coin, that mirrors and reflections are everywhere if you know how to look. And maybe that's the real gift of thinking about black holes as mirrors of the infinite. They remind us that every boundary is also a question mark. Is this the edge or just a doorway? Is this an ending or the start of something nested inside? When you stand between two mirrors, you're staring into endless reflections of yourself. When you stand before a black hole, you might be staring into endless reflections of universes themselves. Which leaves us with a tantalizing thought. If black holes are mirrors, then what happens when you step all the way through one? Does the reflection stare back? Does the inside become the outside? Or do you find yourself gazing into yet another layer, another doll, another infinity waiting to unfold? That's where our next chapter drifts, into the landscapes hidden beyond reflection, where symmetry breaks and the universe shows us what lies beneath its mirrors.
Picture this. You trip and fall into a black hole. Now, most of us would assume that's the end of your story. Curtain falls, lights out, game over. But what if that plunge isn't a one-way ticket to doom, but a doorway to something astonishing? Imagine instead of being squashed into cosmic paste, you tumble into a whole new universe. Not just a pit of darkness, but a hidden world expanding outward, vibrant and alive, like stumbling into Narnia, but with more physics and fewer talking lions. This idea that a black hole could cradle an entire universe within isn't just late-night science fiction speculation. It's a hypothesis that some serious scientists whisper about, their chalkboards littered with equations that suggest black holes might be cosmic wombs. Let's unpack how that could possibly work. A black hole begins with collapse. A star, massive enough to intimidate just by existing, runs out of fuel. Gravity, which has been politely balanced by the star's internal pressure, suddenly wins the tug of war. The star folds in on itself, falling down, 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 until what's left is so dense that nothing, not even light, can escape its pull. That's the version you already know, but here's where the twist comes in. Inside that crushing collapse, conditions get stranger than anything we've ever recreated in a lab. Matter is squeezed, space is bent, time is stretched, and all the rules we cling to begin to wobble.
In that chaos, some physicists suggest a kind of rebirth might take place. The collapse doesn't just stop at destruction, it bounces into creation, like a trampoline you didn't know existed at the bottom of the pit. To someone watching from the outside, all we see is the black hole itself, dark, mysterious, silent. But from the inside, imagine the very same collapse looking like an explosion, a big bang of its own, the start of a universe unfolding. From our perspective, the star died. From the inside perspective, a cosmos was born. It's a trick of relativity. One event, two radically different stories, depending on which side of the horizon you're on. Think of Russian nesting dolls again. Our universe might just be one doll inside a bigger one, which itself is inside an even bigger one. Every black hole could contain its own doll, a whole universe tucked away, expanding on the inside while sealed off from the outside. The structure of reality might not be linear, like a line with a beginning and end, but recursive, like a fractal folding endlessly in on itself. Each collapse births a new expansion. Each black hole seeds a fresh cosmos. Now, here's the wild part. If that's true, then our universe could itself be the interior of a black hole in some larger universe. The Big Bang, the fiery birth of space and time 13.8 billion years ago, might have looked, from some outsider's view, like the formation of a black hole in their cosmos. What they saw as an ending, we experience as a beginning. It's like the ultimate recycling program. Matter collapses, universe expands, repeat. This isn't just poetic, it's supported by math. Solutions to Einstein's field equations of general relativity allow for what's called a white hole, a theoretical counterpart to a black hole where matter bursts outward instead of being sucked in. White holes haven't been spotted in the wild, but they hint at the possibility that the inside of a black hole isn't a singularity, an impossible point of infinite density, but the seed of an entirely new space-time. Instead of crushing everything into nothing, it funnels everything into a new somewhere. Of course, this raises some unsettling questions. If black holes birth universes, do the universes inherit traits from their parents? Maybe the physical constants, the strength of gravity, the speed of light, the masses of particles are like DNA passed down through generations. Universes that work go on to produce stars and galaxies, which in turn collapse into more black holes, spawning further offspring. Universes that don't get the math right simply fizzle out, never forming structure. This idea, sometimes called cosmological natural selection, paints universes as a family tree, evolving over time. In that sense, you're not just stardust, you're also black hole dust, a descendant of some parent cosmos that got its physics tuned just right. But how would we ever know? That's the frustrating part. If we're living inside a black hole, the horizon walls us off from direct communication with the parent universe. We can't wave through the glass and shout, "Hey, thanks for existing." The boundary is impenetrable. Still, there's subtle hints. The very structure of our universe, the way it expands, the way galaxies scatter like confetti, mirrors the behavior you'd expect if we were birthed in such a way. It's not proof, but it's tantalizing. And isn't that what makes science so thrilling? The line between what we know and what we dream is always blurry. We stand here, in a universe that may itself be a black hole's child, speculating about black holes that might contain other universes, speculating further about those universes containing more, like a hall of mirrors that never ends. And if that makes your head spin, you're not alone. Even physicists scratch their scalps over this, half in awe, half in exasperation. To make it a little more relatable, think of it like this. You're sitting in a movie theater, watching a film. The characters on screen have no idea they're inside a movie. For them, the story is all there is. But you, from the outside, know it's just one film among countless others playing in the multiplex. If black holes birth universes, then each new cosmos is its own movie, its own story unfolding. We, the characters, don't know about the projector, the reel, or the bigger cinema out there. We just live our script. This possibility reframes black holes entirely. Instead of tombstones of dead stars, they might be cradles, incubators of existence. Each one could hold within it wonders we'll never see, civilizations we'll never meet, skies that will never overlap with ours. The night sky, sprinkled with black holes, might be less a graveyard, more than a nursery. Each dark speck hiding entire worlds behind its curtain. And here's the kicker. If universes are born inside black holes, what lies inside the black holes of our own universe? Entire chains of reality could be branching downward like a cosmic family tree, endlessly fertile, endlessly mysterious. We might just be one twig on a sprawling forest of universes. That thought is both humbling and electrifying. So, next time you hear the words black hole, don't just think of destruction. Think of birth. Think of hidden skies unfolding in silence. Think of how endings and beginnings might be the same event depending on where you stand. And then ask yourself this. If black holes birth universes, what happens when we follow the thread all the way back? What birthed our universe's black hole? Is there a parent cosmos watching us from across the glass, just as we wonder about what lies beyond? That's the puzzle waiting in the next chapter. Because if universes can be born, then we must ask, what does it mean for them to die?
Imagine running your hand across the universe and realizing it's not empty air, but something more like a sheet you could tug, stretch, or wrinkle. That's the strange truth physics hands us. Space isn't just nothingness, it's a fabric. Not fabric like your favorite hoodie, but fabric as in an invisible stage that everything, stars, planets, black holes, you stand on. Einstein's great aha moment in the early 1900s was realizing this stage isn't stiff. It bends, it curves, it warps under weight. And that simple yet mind-bending idea rewrote our picture of reality. Suddenly, gravity wasn't some magical force pulling apples toward the ground. It was the curve of space itself telling matter where to move. Space became elastic. To picture this, grab a mental bedsheet. Stretch it tight. Now plop a bowling ball in the middle. The sheet dips, and smaller objects rolled across it spiral toward the dip. Congratulations! You've just explained the orbits of planets around the Sun. Earth isn't being tugged by some invisible string, it's surfing a curve carved into space by the Sun's mass. The bigger the object, the deeper the dent. That's why Jupiter flexes its cosmic weight so powerfully, while the Moon makes a dip you'd barely trip over. And then there are black holes. They don't just press into the sheet, they punch through it, tearing wells so deep they vanish into another dimension of mystery. But here's the kicker. You're not just floating on this sheet, you're part of it. Every atom in your body contributes, minuscule though it may be, to the overall warp of space. Yes, technically, you bend the universe. Your mere existence leaves a tiny imprint on the fabric of reality. Not bad for a bag of stardust eating breakfast cereal. You might not send planets spiraling, but in the cosmic geometry, you're not invisible. The fabric of space isn't static either. It's alive with ripples. In 2015, detectors on Earth finally picked up gravitational waves, subtle shutters in spacetime itself. These waves were born from black holes smashing together billions of light years away, like cosmic cymbals clanging. By the time they reached us, the ripples were smaller than the width of a proton, but still detectable. Think about that. The universe literally rang like a drum, and we heard it. We didn't just see space, we felt its vibrations. That's like realizing your room isn't silent, it's humming, softly vibrating with ancient echoes. And what does this mean for galaxies, stars, and everything else? They're all boats on this invisible ocean,
floating and drifting according to the tides of space. Galaxies cluster where the fabric dips most, forming a vast web, while in between are cosmic deserts, expanses of nearly empty sheet. If you could zoom out far enough, you'd see the universe's large-scale structure as a sort of foam, filaments of galaxies stretching like strands of cotton candy, leaving yawning voids in between. The whole thing looks less like a starry sky and more like a three-dimensional spiderweb spun by space itself. Of course, this fabric isn't something you could grab and sew. It's geometry more than substance, defined by how objects move through it. Einstein described it with equations that look intimidating enough to scare away even math enthusiasts, but at heart it's the same principle as rolling marbles around a dimpled sheet. Gravity is just the shape of space telling matter how to move. Matter, in return, tells space how to curve. It's a cosmic conversation that never ends, a call and response between what exists and the stage it rests on. Black holes, naturally, are the fabric's most extreme conversation partners. They press the sheet so deeply that no marble can escape. From outside, it looks like an endless pit. From inside, who knows? Maybe, as we mused before, it stretches into new universes. What's clear is that black holes don't merely sit on space, they radically reshape it. They drag space itself around them as they spin, a phenomenon called frame dragging. Imagine stirring a spoon in honey. The honey swirls with it. A rotating black hole stirs space-time the same way, sweeping up everything near it into a whirl. If the universe had a cosmic spoon, black holes would be doing the stirring. But here's something even stranger. The fabric of space is expanding. Our universe isn't just sitting still, it's stretching like dough rising in an oven. Galaxies aren't racing through space so much as space itself is swelling between them. The farther away a galaxy is, the faster it seems to recede, carried outward by the stretching sheet. And just when scientists thought this expansion might slow down, they discovered dark energy, an invisible push that's making it accelerate. It's as if the cosmic fabric is not just pliable, but restless, stretching faster and faster, as though it's had too many espressos. So where does that leave us, humble riders on this infinite sheet? It means everything you've ever known, every star, every galaxy, every whisper of light has been floating, bending, and rippling across a fabric that isn't visible, but is undeniably there. The story of the cosmos is written not only in the stars themselves, but in the curves and folds beneath them. Gravity isn't a mysterious pull from afar, but the shape of the stage beneath our feet. And when we gaze at the night sky, we're not just looking at stars in space, we're looking at the wrinkles of space itself. Think of it this way. You're living on a trampoline that never ends, stretched across infinity. The trampoline dips under the weight of stars, ripples when galaxies collide, and stretches as time marches on. You can't step off it, but you can feel its effects everywhere. Black holes, supernovas, even your own footsteps, all of it is woven into this cosmic fabric. And maybe the most astonishing thing is how delicate it all is. A single wave crossing billions of light years can whisper into detectors on Earth. A black hole can spin space like taffy. And yet through all this bending and rippling, the universe maintains its form, holding us in its invisible embrace. The next time you look up, don't just picture stars scattered in a void. Imagine the sheet beneath them, dipping and curving, an endless fabric holding everything in place. And then ask yourself the question that naturally follows. If the fabric of space is so flexible, so alive, what happens when it tears? That is where our journey heads next, because the universe may not always stay neatly stitched together. What if everything you've ever known, your shoes, your breakfast toast, your favorite embarrassing childhood memory,
sprang from an explosion that wasn't so much a bang as it was a balloon inflating faster than you could say cosmic popcorn. The universe, all 13.8 billion years of it, began in a single instant of furious expansion we've come to call the Big Bang. Don't imagine fireworks, though. There were no sparks lighting up a night sky, no sound booming across the void. Sound needs air, and back then, there wasn't even space, let alone air. It was the birth of everything: space, time, energy, matter, like someone flipped the switch on reality itself. Now here's where it gets deliciously weird. Some scientists wonder, what if that very beginning, the bang, wasn't the start at all? What if it was the inside-out eruption of a black hole in some other universe? Imagine a cosmic nesting doll. Inside one doll is another, and inside that another, and on it goes. Could our Big Bang be the dramatic interior reveal of a black hole's collapse elsewhere? Suddenly, the idea of beginnings starts to feel more like doorways. The end of one thing could be the start of something else. The universe might just be the ultimate recycler. But let's rewind. Right after the Big Bang, things got intense. In the first fraction of a second, the universe inflated at a pace so absurd that if you blinked, you'd have missed a trillion times expansion. This wasn't ordinary stretching, this was space itself ballooning. Think of it like taking a loaf of raisin bread dough and putting it in the oven. The raisins, our galaxies, don't race outward. Instead, the dough between them expands, carrying everything apart. Except this dough wasn't baking slowly, it went from crumb to cosmos almost instantly. Talk about fast food. Eventually, things cooled enough for particles to slow down and form atoms. Hydrogen and helium stepped onto the stage, the simplest building blocks of everything that would come later. Stars, planets, cheeseburgers. Yep, all of it traces back to those first atoms forged in the aftermath of the Big Bang. It's as if the universe cooked a giant cosmic soup and kept the recipe very, very simple. Just hydrogen, helium, and time. Lots of time. But the best part, we can still hear the echoes of that moment today, not with our ears, but with antennas and detectors. This echo is called the cosmic microwave background, or CMB for short. Picture the universe as a room where a firework once exploded. Long after the sparks die, a faint, smoky haze still lingers. The CMB is that haze, an afterglow of light stretched across the entire sky. It's not bright, it's more like faint static humming in the background. In fact, if you've ever tuned an old TV to a dead channel and seen that snowy fuzz, about 1% of that static came from the Big Bang itself. Every time your grandparents smacked the TV antenna in frustration, they were shaking hands with the birth of the universe. This cosmic afterglow is priceless because it's a snapshot of the universe when it was just 380,000 years old. Basically, it's baby photo. Scientists use it to measure everything from the age of the cosmos to its shape. And the weird thing is, the picture shows tiny temperature ripples, warm spots and cool spots scattered like freckles across the sky. Those tiny differences eventually became galaxies, stars, and planets. Without those little wrinkles, the universe would just be a smooth, dull soup of particles, and we wouldn't be here. Turns out, imperfections are what make reality interesting. The universe, like humans, thrives on its quirks. Now, back to the black hole theory. If our universe really was born from one, then maybe what we call a singularity, the infinitely dense point at the heart of a black hole, isn't an end at all, but a bridge. On one side, collapse, on the other, creation, like flipping a sock inside out. From outside, it looks like destruction. From inside, it's a big bang. This idea doesn't just tickle the imagination. It also makes you wonder if black holes scattered across our universe are spawning new baby universes as we speak.
Right now, while you're reading this, a trillion parallel realities might be inflating inside the bellies of black holes. In one of them, maybe you became a professional llama trainer. The possibilities are endless. Of course, this raises an awkward question. If universes can be born inside black holes, who's to say ours isn't just one layer in an endless cosmic matryoshka? Maybe there's no single beginning, just infinite echoes, one universe budding from another like soap bubbles merging and separating. If that's true, then the Big Bang wasn't the first note in a song. It was just one chord in an eternal symphony, and we're sitting here on a tiny blue planet trying to hum along. The most haunting part of the story is how accessible the evidence is. The CMB isn't hidden in some faraway galaxy. It's literally all around you, saturating every inch of the sky. If your eyes could see microwaves instead of visible light, you wouldn't see stars when you looked up at night. You'd see a glowing fog, the memory of creation itself. Every sunset, every meteor streak, every quiet night sky is layered over this ancient echo. It's like living inside a painting and only gradually realizing the canvas itself is humming with color you never noticed before. And so we are here, caught between theories and possibilities. Was the Big Bang a singular beginning, or was it the child of a black hole in another realm? Is the cosmic microwave background a memory of one creation, or just one echo among countless others? We don't have final answers, but the beauty lies in the questions themselves. After all, when you press your ear to the universe, it doesn't whisper a tidy explanation. It hums with static, faint, but eternal, the sound of beginnings reverberating forever. And if beginnings can be echoes, then maybe endings can be as well. Which leads us to an even stranger riddle. If the universe had a first act, what will its final curtain look like? Will everything fade into silence, or will the echoes crescendo into yet another beginning? That, my friend, is the mystery waiting just beyond the horizon of our next chapter. Imagine this. You're standing in front of a door. On one side, your room. On the other side, instead of your hallway or kitchen, it opens into a cafe on Saturn, where the barista is a floating alien jellyfish. Sounds like something out of a late-night sci-fi binge, right? Well, that's pretty much what wormholes promise us. A cosmic shortcut, a tunnel through space-time that might let you leap from one distant place to another without ever having to slog through the endless miles in between. Wormholes are like cheat codes for the universe, only instead of pressing up, up, down, down, left, right, you bend space-time into a fold and slip through. The idea comes straight from Einstein's equations. When he worked with his collaborator Nathan Rosen back in the 1930s, they realized that the math of general relativity allowed for bridges, connections between 2 points in space-time. These became known as Einstein-Rosen bridges, though wormholes is the much catchier name. And honestly, wormhole works perfectly. Think of an apple with a worm burrowing through it. The worm doesn't crawl around the hole outside, it digs a tunnel right through. What would take you ages to walk around, the worm crosses in seconds. Nature's express lane. But of course, the universe doesn't hand out easy rides without complications. Wormholes, at least as far as we know, aren't exactly stable. Left to their own devices, they'd collapse faster than a bad soufflé. That's where the concept of exotic matter comes in. Not exotic as in sipping cocktails with umbrellas on a beach, but exotic as in strange, negative energy stuff that doesn't behave like the matter we're used to. In theory, this exotic matter could hold a wormhole open long enough for something, maybe even someone, to pass through. Without it, stepping into a wormhole would be like trying to sprint through a collapsing tunnel, not ideal for interstellar tourism. Still, wormholes ignite our imagination like little else. Movies love them. From Interstellar to Doctor Strange, they show up as glowing portals or whirling tunnels of light. And while Hollywood takes, let's just say artistic liberties, the seed of the idea is rooted in real physics. Mathematically, the possibility is there. Whether nature actually builds them, though, is a whole other story. It's kind of like finding out your favorite theme park has blueprints for a new roller coaster. Just because it's possible on paper doesn't mean it's already been built. Now, let's play with the scale for a moment. Wormholes don't have to connect galaxies or universes. In principle, they could be microscopic, tiny tunnels flickering in and out at the quantum level. If they exist down there, they'd be ridiculously short-lived, popping open and slamming shut before you'd have time to say, "Did you see that?" But that sparks another wild idea. What if those fleeting connections are part of the way reality knits itself together? If spacetime is fabric, maybe wormholes are the little stitches running through the threads, invisible until you look very, very closely. And then there's the ultimate mind-bender, wormholes as time machines. You heard me right. According to certain solutions in physics, if you moved one end of a wormhole at near light speed and then brought it back, you could create a time difference between its two mouths. Enter one side, pop out the other, voila, you've skipped ahead or maybe even back in time. Of course, this leads to the usual time travel headaches, paradoxes, loops, questions like, what happens if you stop your grandparents from meeting? Suddenly, the universe feels less like a calm classroom and more like a messy writer's room for a sci-fi show. The biggest question, though, is whether wormholes are real or just math daydreams. We haven't observed one. No telescope has ever caught a wormhole glowing in the darkness, but black holes themselves were once just theoretical beasts scribbled on paper, and now we've literally photographed one. So who's to say wormholes won't make the leap from chalkboard doodle to cosmic reality someday? Science, after all, has the habit of turning imagination into evidence. Picture this. Somewhere out there, between galaxies, hidden in the folds of spacetime, could be a tunnel waiting for discovery. Maybe it's stable, maybe it's fragile, maybe it's as useful as a door painted on a brick wall. But the thought alone, just the possibility that you could step into one place and step out light years away, gives the cosmos an air of secret passageways. The universe starts to feel less like an open desert and more like a mansion full of hidden doors, each one humming with mystery. And if wormholes are real, then they might not only connect regions of space, but also different universes altogether. That's where things get really juicy. Imagine, every black hole could be hiding a wormhole mouth, leading not to destruction, but to an entirely different cosmos. Maybe universes are strung together like beads on a necklace, linked by unseen tunnels. Or maybe they're sprawled out like an endless library, with wormholes as the secret ladders connecting one shelf to another. If that's the case, then every question about where shifts into something stranger. Maybe there isn't just one reality, but countless ones stitched together in ways we're only beginning to dream. And so as you sit with this thought, you can almost hear it, the hum of possibility, the quiet thrill that maybe the universe is full of secret shortcuts, doors we haven't yet unlocked. Wormholes remind us that the universe isn't just wide, it's layered, folded, full of surprises hidden in its very fabric. But if there are doors, then the question becomes who or what has the keys? And that mystery leads us straight into our next step, where the idea of parallel worlds begins to shimmer just beyond reach.
Imagine for a moment that light, the fastest thing we know, the universal sprinter who never loses a race, suddenly gets caught in an eternal traffic jam. No escape, no shortcuts, just endless circling around the same spot forever. Sounds like a punishment reserved for cosmic overachievers, doesn't it? Yet this is exactly what happens around black holes and a strange boundary called the photon sphere. It's the one place in the universe where beams of light, which usually zip away to infinity like restless teenagers, are forced to loop endlessly like marathon runners on a track with no finish line. Now, to understand why this is such a bizarre spectacle, let's rewind to the basics. Light is fast. Not fast in the sense of your friend bragging about running 5 kilometers before breakfast, but fast in the ultimate sense, nearly 300,000 kilometers per second. If speed had a crown, light would wear it proudly. And in the everyday world, nothing has the power to hold it back. Flashlight beams, sunrise rays, even the glow of your phone screen, they all spill out freely. But black holes are no everyday objects. Their gravity turned up to levels so extreme that space itself bends inward, warping the very stage on which light tries to perform. At the photon sphere, located just outside a black hole's event horizon, this tug-of-war reaches a surreal balance. Light doesn't plunge straight in, nor does it escape to freedom. Instead, gravity's pull curves its path so much that the light just keeps circling. It's like a moth trapped in orbit around a flame, except here the moth is the flame, and the trap is gravity's invisible grip. If you could hover safely nearby, and let's be real, you couldn't, you would see beams of light chasing each other in perfect loops, racing endlessly without ever leaving. Now, here's the strange part. If your eyes could handle it, standing at the photon sphere would let you see the back of your own head, made entirely out of light. Why? Because the photons bouncing off you could loop all the way around the black hole and smack straight back into your eyes. A black hole mirror, reflecting you in the weirdest, most cosmic way imaginable. Forget bathroom mirrors, this is nature's funhouse on steroids. Now, let's talk about how this looks. We've all seen artists' impressions of black holes with glowing rings of fire swirling around them. That glow? That's not the black hole itself. It's light caught near the photon sphere, bending and curving until it forms a bright halo. This is why black holes look like glowing donuts instead of featureless voids. The light isn't escaping, but it isn't gone either. It's trapped in a kind of purgatory, giving us a last glimpse of brightness before gravity silences it completely. And the sheer poetry of it all is irresistible. Light has always symbolized freedom. Sunlight breaking through clouds, headlights cutting through fog, stars prince-picking the night sky. But here, in the shadow of a black hole, freedom itself is shackled. The fastest traveler in the cosmos becomes a prisoner, endlessly looping in a circle no wider than a heartbeat on a galactic scale. It's as if the universe whispered, "Even light must obey." But of course, light isn't really choosing to orbit. It's following the rules of space-time itself. Einstein's theory of general relativity showed us that gravity isn't just a force pulling things down, it's the bending of the very fabric of reality. Light doesn't weigh anything in the traditional sense, but it still follows the curves of space like a marble rolling across a warped trampoline. Around a black hole, that trampoline isn't just warped, it's folded into a funnel so steep that once light crosses a certain threshold, it has no choice but to spiral inward. The photon sphere sits right at the edge of this cosmic cliff, a fragile balancing act between escape and doom. The beauty of this idea isn't just in the math, it's in what it tells us about perspective. Think of light as a storyteller. Every photon that reaches your eyes has traveled, sometimes for billions of years, to bring you a message. Hey, this is what that star looked like when I left. But photons trapped at the photon sphere never get to deliver their message. They run in circles, repeating their story to themselves, never reaching an audience. It's tragic and elegant all at once, like a song stuck on repeat in an empty room. Of course, this raises the inevitable question, what would it actually look like if you were foolish enough to get near the photon sphere? The answer is brain-bending. You wouldn't just see stars ahead of you, you'd see stars behind you, above you, maybe even multiple copies of the same star in different positions. Light wrapping around the black hole would create optical illusions so wild that your brain might throw in the towel and stop trying to process them. Imagine standing in a hall of mirrors, except the mirrors are made of gravity, and the reflections are stitched together by space-time itself. This isn't just science fiction speculation either.
When the Event Horizon Telescope snapped that historic image of a black hole in 2019, what we saw wasn't the black hole's surface. It has no surface. What we saw was light trapped around the photon sphere, bent into that glowing ring. Humanity's first photograph of a black hole was really a portrait of imprisoned light. Think about that. We didn't just capture the silhouette of darkness, we captured brightness caught in a gravitational grip, forever unable to escape. It makes you wonder about the cosmic role of light. For us, it's a beacon of direction, warmth, life. Without light, plants don't grow, days don't dawn, Netflix doesn't stream. Yet at the photon sphere, light plays a different role. It becomes the paint outlining the shadow of gravity's masterpiece. It turns into a reluctant artist, sketching the shape of something we could never see otherwise. Without that trapped halo, black holes would remain invisible, slipping silently through space. And there's a strange irony in all this. The most extreme prisons of the universe, the black holes, are revealed to us only because their prisoners, the photons, are forced to circle them. Without captured light, we'd have no clue where the darkness lives. In other words, even in captivity, light finds a way to speak. As you sit with that image, of brightness bound yet illuminating, it lingers with a certain weight. What else in this universe looks free but is secretly tethered? What other truths hide just outside our vision, waiting for us to notice the faint glow circling in the dark? The photon sphere reminds us that the cosmos is never simple. Even light, that symbol of escape and speed, can be bound to orbit forever. And as the thought curls in your mind, you can feel the story sliding towards something even stranger. Because if light itself can be trapped, what happens when entire worlds of possibility exist just out of reach, flickering across hidden boundaries? That question opens the next door, where the idea of parallel worlds begins to shimmer on the horizon.
Here's a thought experiment to bend your brain before bedtime. What if our entire universe, the galaxies, the stars, the Milky Way, the coffee you spilled this morning, wasn't the main show at all, but just the inside of a black hole living inside another, bigger universe? Imagine being told that everything you've ever known exists in the cosmic equivalent of a Russian nesting doll, one universe tucked inside another, and another, and another. At first glance, it sounds like a plot twist written by someone who's had too much caffeine. But then again, that's often what the universe feels like, a prank pulled by physics. Let's roll the film back to how black holes are born. Picture a star so massive that when it runs out of fuel, it can't hold itself up anymore. Its core collapses inward, gravity grabs the wheel, and in a matter of seconds, the star folds itself into a tiny, ridiculously dense point. This collapse is so extreme that it doesn't just make a dead star corpse, it tears a hole in space-time itself. Now here's where it gets cinematic. What if that collapse, instead of being the end of a story, is the beginning of another? Some physicists have whispered about the possibility that a black hole doesn't just crunch matter into nothingness, but funnels it into a new universe, sealed off and expanding on the other side. The idea is almost poetic. On one side of the black hole, destruction reigns, stars shredded, light swallowed, matter squeezed to oblivion. But on the other side, creation bursts forth, matter, energy, and space-time expanding like the opening credits of a brand new cosmic saga. You could think of a black hole as the universe's recycling plant. Trash goes in, new reality comes out. Not exactly a perfect system for curbside pickup, but you get the idea. The fractal imagery here is irresistible. Russian dolls stacked endlessly inside one another. Each universe massive and self-contained, but actually born from the collapse of a star in a larger universe.
If you zoom out far enough, maybe the parent universe that gave birth to ours was itself tucked inside a bigger one, and that one inside another, and another. Its universes all the way down. And suddenly, your morning struggle of what should I eat for breakfast feels suspiciously trivial compared to how many universes deep are we nested in. Now, this isn't just wild speculation written on a napkin after a long night. It comes from hints in physics. For example, when matter collapses into a black hole, equations from general relativity predict a singularity, a point of infinite density. Infinite, of course, is physics' way of saying, we don't know what's happening here. But instead of a dead end, some cosmologists propose that this singularity could explode outward, just as our universe supposedly did during the Big Bang. What looks like an ending from the outside could feel like a beginning from the inside. Imagine being born inside a balloon while the balloon is being inflated. You'd never see the hand blowing it up, only the expansion all around you. The catch is, from our perspective, we'd never know for sure. If our universe were the inside of a black hole, the event horizon of that black hole would be the boundary of our universe. We can't see beyond it. It's like being locked in a cosmic theater with the curtains drawn. You can marvel at the show, but the backstage is forever hidden. In fact, this idea eerily echoes what we already see. Our observable universe has a cosmic horizon, a limit beyond which light hasn't had time to reach us. It behaves suspiciously like a boundary. Coincidence? Or a hint that we're sitting inside something grander? And if this theory holds, then black holes in our universe might be budding universes themselves. Every time a massive star collapses and forms one, perhaps it's not just a funeral, it's a birth announcement. From our side, we see tragedy. The star disappears, light bends, gravity rules. From the other side, beings could be watching their cosmos expand, galaxies forming, stars igniting, life pondering their morning coffee. For all we know, entire civilizations are already thriving in universes birthed by black holes in our own sky. Think about that next time you look up at the stars. You might literally be staring at someone else's Big Bang. Of course, some scientists roll their eyes at this idea. They argue that it's beautiful but speculative. We have no way to peek inside a black hole to check. And even if we could, space-time itself prevents messages from traveling out. It's like trying to get gossip from a friend who never replies to texts. You suspect there's a story, but you'll never know the details. Still, isn't that mystery what makes it so irresistible? Physics doesn't just give us answers, it gives us questions big enough to keep us up at night. And there's also something humbling in imagining universes inside universes. It shrinks our sense of cosmic importance. We like to think of our universe as the grand stage, the ultimate reality. But what if we're just a subplot in a larger story? One chapter in an infinite book? Maybe every black hole in the night sky is a bookmark leading to another tale. Maybe there's a universe inside the black hole at the center of our galaxy. And within that universe, another black hole. And within that black hole, another. Infinity starts to feel less like an abstract concept and more like the architecture of reality. And here's a little kicker. If black holes really do birth new universes, then perhaps the laws of physics in those universes differ slightly from ours. Imagine a kind of cosmic natural selection where only universes with stable laws can give rise to stars, galaxies, and eventually life. In that sense, we're here because our parent universe passed down the right combination of cosmic ingredients. Suddenly, our existence feels like part of an evolutionary chain, not just of biology, but of entire realities. Talk about family trees. The roots might stretch across universes. So here we are, pondering whether we live in a cosmic Russian doll, wondering if black holes are cradles instead of coffins, and realizing that the ultimate truths may forever hide behind horizons we cannot cross. But even if we can't know for sure, the idea itself changes how we see the universe. It transforms black holes from terrifying voids into potential gateways of creation, from endings into beginnings. It reframes the night sky into something more alive, more recursive, more infinite than we dared to imagine. And as this thought drifts into your mind, it nudges you toward the next question, the next leap. Because if universes can be born inside universes, if reflections stretch infinitely in every direction, then maybe the mirror doesn't just stop at black holes. Maybe there are worlds parallel to ours, separated not by distance, but by possibility itself. And that, my friend, is a rabbit hole even stranger than Russian dolls. One we'll step into next.
Here's a riddle to start with. How heavy is infinity? If your brain just short-circuited a little, don't worry, you're not alone. Infinity isn't a number you can stick on a bathroom scale or scribble on a receipt after buying way too many groceries. It's not even a number in the usual sense. It's more like a horizon. No matter how far you walk toward it, there's always farther to go. And yet, in the realm of black holes and the universe itself, infinity is not just poetic decoration, it's a serious guest that keeps barging into the math and refusing to leave. Take black holes, for example. When physicists run Einstein's equations on a collapsing star, they end up with something they call a singularity, which is basically the universe saying, I don't know what happens here, but the density is infinite. Imagine stuffing the entire Earth into a marble and then squishing that marble down smaller and smaller until it has no size at all, but still contains all the mass. That's what infinity does to our equations. It takes a concept that makes sense, like density, mass divided by volume, and breaks it by dividing by zero. Infinity in this sense isn't a tidy solution. It's a red warning light, a kind of cosmic error message flashing, "System overloaded, try again later." And yet, infinity isn't always a dead end. Sometimes it's the exact opposite. Think about the universe itself. Look up at the night sky, past the stars, past the galaxies, past everything your eyes could ever catch. Does it go on forever? If it does, that means infinity is baked into reality itself. Every direction you travel, there's more universe waiting. It's like the world's longest Netflix series that never ends. No matter how many episodes you binge, there's always another season. Infinity can feel claustrophobic when it traps equations, but liberating when it tells us the universe might have no edge. To wrap your head around infinity, you have to accept that not all infinities are equal. Some are bigger than others. That sounds ridiculous, right? Bigger than infinity? But mathematicians like George Cantor showed this over a century ago. Imagine counting numbers 1, 2, 3, 4, forever. That's an infinity. Now imagine all the fractions, halves, thirds, quarters, sevenths, and even denser infinity. Then, beyond that, the infinity of all real numbers, which is bigger still. Suddenly, infinity isn't one thing, it's a whole zoo of different sizes of endlessness. You can get lost in that zoo if you're not careful. Black holes drag this weirdness into physics. When you calculate the curvature of spacetime at the center of a black hole, it doesn't just bend, it shoots off to infinity. It's like rolling a bowling ball into a trampoline, except instead of creating a neat dent, the ball keeps sinking forever, ripping the fabric downward, with no bottom. For physicists, that's maddening. They want answers. Instead, infinity laughs at them from the chalkboard. Some think this means we're missing a deeper theory, one that merges Einstein's relativity with quantum mechanics into a cleaner description that banishes those infinite quantities. Others think infinity is simply the price of admission when exploring reality this extreme. The universe itself also toys with infinity and time.
Will it expand forever? If so, then the clock keeps ticking endlessly, galaxies drifting apart like friends after high school who never text back. The alternative, if gravity eventually halts the expansion and pulls everything inward, would be a big crunch, an ending. But current evidence points toward eternal expansion. In other words, infinity not only shapes the present, but also stretches into the future, promising a timeline that never stops unfolding. There's a funny contradiction here. Infinity makes us feel tiny, lost in a scale so vast we can't possibly comprehend it. And yet, thinking about infinity also elevates us. After all, here we are, tiny creatures made of stardust, daring to even imagine it. Ants don't sit around wondering about endless time. Cats don't worry about multiple sizes of infinity, at least not when we're watching. But humans, armed with curiosity and the occasional bad math pun, dare to hold infinity in their minds, if only for a moment, before it slips away again. Think of infinity like standing in front of two mirrors facing each other. Your reflection bounces back and forth, smaller and smaller, forever. That's not truly infinite. You'll eventually hit the limits of the glass, the photons, the physics, but it gives you a taste of what infinity feels like. Or picture the old Hilbert's Hotel thought experiment. Imagine a hotel with an infinite number of rooms, all full. Now, someone new shows up and asks for a room. No problem, says the manager. He just moves everyone up by one room. Guest in room 1 goes to room 2, guest in room 2 goes to room 3, and so on. Suddenly, room 1 is free. Infinity, unlike any regular number, always has space for more. Black holes and the universe itself seem to carry that same paradoxical logic. Bottomless, limitless, but strangely accommodating. But here's the kicker. Infinity is both real and unreal. Real because it shows up in the math and may be written into the fabric of reality. Unreal because we can never touch it, never finish counting to it, never pin it down in practice. It's like chasing the horizon, always there, never reachable. When we say black holes have infinite density, or the universe stretches infinitely outward, what we're really saying is our current tools break down when faced with this kind of vastness. Infinity is both the shadow at the edge of our equations and the light that leads us forward. So, when you think of infinity, don't picture it just as a giant number sitting smugly at the end of the number line. Think of it as a mirror reflecting back at us, showing both the limits of our imagination and the courage it takes to push beyond those limits. Infinity humbles us, but it also inspires us. It tells us the game isn't over, that there's always more to explore, more to discover, more to dream about. And maybe that's the real weight of infinity. Not crushing, but exhilarating. It presses down when we face paradoxes we can't solve, but it lifts us up when we realize we're allowed to even try. So, the next time your mind starts to ache thinking about infinity, remember, that ache is proof you're stretching your brain into places it's not used to going. And in stretching, you're brushing up against the very fabric of the cosmos. Which leads us naturally to the next wonder. If infinity pushes us to question boundaries, what happens when boundaries themselves dissolve? What if the edges between realities blur and multiple universes stack not in size, but in possibility? That, dear traveler, is where the idea of the multiverse begins, and it's waiting for us just beyond this chapter. Have you ever looked at a math equation and thought, wow, that's gorgeous? No? Don't worry, you're not alone. For most people, equations look like alien hieroglyphs scribbled by some cosmic accountant. But here's the twist. Hidden inside those squiggles and symbols is the very script of the universe. Einstein's equations in particular are less like boring homework and more like sheet music written by the cosmos itself. Think of them as the universe's Spotify playlist, except instead of catchy pop songs, it's playing symphonies of space, time, and gravity.
And the coolest part? You don't even need to know advanced math to feel their rhythm, because the poetry they write shows up everywhere around you. Imagine spacetime as an enormous trampoline. Drop a bowling ball in the middle and the surface dips. That's Einstein's idea of gravity, not a mysterious invisible force pulling you down, but the very shape of space, curving around objects. His equation describing this is like a cosmic recipe. Matter tells spacetime how to bend, and spacetime tells matter how to move. It's like a dance-off between geometry and mass. And spoiler alert, the geometry always wins. You could almost picture Einstein, chalk in hand, scribbling on a board like a musician composing a song, except his notes reshaped how we see the universe forever. Now here's where the equations stop being just math and start feeling like poetry. They don't merely describe falling apples or planets orbiting stars. They whisper about black holes, those mysterious pits where gravity squeezes space and time into a knot so tight that not even light escapes. When you look at the equations carefully, they seem to say, "Psst, universes might be hiding in here." That's right, some scientists believe black holes could be more than stellar corpses. They might be the wombs of new universes, stitched into the mathematics like a secret message. Suddenly, equations don't feel cold. They feel like riddles written by an author who never runs out of paper. Think of an equation like E equals mc squared. You've probably seen it printed on t-shirts, coffee mugs, and maybe even tattooed on someone who thought they'd look deep at parties. But behind the merch is an idea so mind-bending, it might as well be wizardry. Energy and matter are two sides of the same coin. The chair you're sitting on, the light bouncing into your eyes, even the atoms in your body, they're all frozen energy, condensed starlight. It's math telling you that reality is basically made out of fireworks that decided to settle down. That's not dull. That's pure poetry. Here's another way to look at it. Equations are the universe's emojis. When you don't have words big enough to explain what space is doing, you reach for symbols that capture the feeling. Einstein's field equations look like abstract doodles, but they encode every cosmic drama: galaxies colliding, stars exploding, black holes spinning. If the universe is a novel, then math is the language it's written in. Sure, not everyone is fluent, but even if you don't speak the equations, you can feel their music in the way planets swing around stars or the way light bends near something massive. It's like listening to opera in a language you don't understand, but still getting goosebumps. Picture an artist painting with numbers instead of colors. That's essentially what physicists do. Where a poet might describe longing with metaphors of oceans or skies, Einstein did it with tensors and metrics. His lines of math sketch invisible curves, mapping how time ticks differently near a mountain than at sea level, or how light stretches when the universe expands. There's a certain drama in realizing those little squiggles decide whether your GPS finds your house or drops you in the next town over. Math isn't abstract, it's practical magic. And then there's the sheer audacity of equations predicting things before we ever see them. Black holes? They came out of the math first, decades before telescopes confirmed their shadows. Gravitational waves? Written in equations long before we built instruments sensitive enough to feel their tiny ripples. It's like math is the spoiler alert of the cosmos, whispering the next plot twist before anyone else has a clue. Imagine reading a script and finding a note in the margin that says, "By the way, in Act 3, two black holes crash together and shake the universe." That's the power of an equation. It's also worth noting how strange it is that our brains, which evolved mainly to keep us from being eaten by lions and to help us find berries, can grasp this kind of thing at all. Equations are abstract, yes, but somehow they map perfectly onto the universe. The fact that math works to describe reality feels almost suspicious, like the universe is leaving us Easter eggs. Some philosophers even wonder if the universe is math at its core, a grand equation running on infinite cosmic paper, crunching numbers while we live out the results. If that's true, then learning equations is less about solving problems and more about learning the lyrics to the universe's song.
And just like a good tune, once you catch the rhythm, you can't help but hum along. Suddenly, what looked like nonsense chalk on a blackboard becomes a kind of cosmic poetry slam, each line rhyming with the stars, black holes, and galaxies. It's like finding out the universe has been speaking to you all along. You just needed to learn its dialect. And so we find ourselves staring at Einstein's symbols and realizing they're not dry relics of a classroom. They're stanzas in a living poem, a song about gravity and time, a script that lets universes bud from the darkness of black holes. We are not just reading equations, we are listening to the symphony of reality itself. The only question now is whether we're ready to follow the music to its next verse, where the boundaries of math blur into something even stranger, an edge where the language of numbers begins to break down, and something entirely new waits beyond the chalkboard. Have you ever woken up from a dream that felt so real you had to double-check which world you were actually in? Maybe you dreamed you were back in high school, trying to find your locker, or suddenly you're living on a beach where the ocean whispered your name. The funny thing is, when we talk about dreams of other universes, science doesn't drift too far from that same feeling. What if this place, the one we take for granted with its familiar stars and gravity keeping your coffee in the cup, is just one version of reality? And what if there are others, universes, stacked and scattered like cosmic cities, each with its own quirks, rules, and physics, waiting out there like chapters we haven't read yet? Our universe is a strange enough story already. It has galaxies twirling like ballerinas, black holes swallowing light, and a mysterious dark energy that's basically the fine print nobody understands. But when physicists let their minds wander, they ask an even stranger question. What if ours isn't the only universe? What if we're just one bubble in an endless cosmic bubble bath? It sounds playful, but the idea is deadly serious in modern science. These aren't just bedtime speculations. They come out of equations and theories that try to explain why our universe looks the way it does. In fact, some versions of the story suggest that black holes, the same monsters we usually fear, could be doorways into entirely new universes. So in a way, when you stare into the night sky, you're not just looking at stars. You might be looking at seeds of other cosmoses, seeds that in another reality could sprout into universes where even the laws of math or physics don't match ours. Let's play with this for a moment. Imagine a universe where gravity is just a little stronger. Stars would burn out too quickly, collapsing before life ever gets a chance to stretch its legs. In another universe, maybe gravity is weaker, and galaxies never really clump together. They just drift apart like lonely islands, too spread out for complex life to ever form. Some universes could sparkle with colors we can't even imagine, because the very physics of light might be different. It's a dizzying menu of possibilities, like wandering into a cosmic ice cream shop, where the flavors range from infinite chocolate to gravity soup. And here's the kicker. Somewhere, buried in these possibilities, there might be a universe that looks almost identical to ours, except maybe you were born 5 minutes earlier, or dinosaurs never went extinct, or coffee never became a thing, though honestly that last one feels too dystopian to contemplate. The dreamlike part of all this is that physics itself doesn't entirely forbid it. Inflation theory, one of the big ideas explaining how the universe ballooned in its earliest moments, predicts that space may keep bubbling endlessly, spawning new universes like popcorn in a pan. Each universe comes with its own settings, like a video game menu. Gravity dial turned up, time ticking faster, chemistry laws shuffled around. We, of course, just happen to live in a version where things balance out enough for stars, planets, and the internet to exist. Lucky us. And then there's the black hole idea, which takes things to an even more cinematic level. Picture this: a massive star dies, collapses under its own weight, and forms a black hole. To us, from the outside, it looks like a dark abyss from which nothing can return. But what if, inside that abyss, the collapse sparks the birth of a new universe? It's as if the death of one star is the womb of another cosmos. That means every black hole you see out there in the night sky could secretly be a universe in its own right, bubbling away beyond the event horizon. And who knows, Maybe our own universe was born that way, the offspring of some larger cosmos, like a cosmic family tree branching infinitely in all directions. It's Russian dolls all the way down, except instead of tiny wooden figures, each layer is an entire universe. But here's where it gets even stranger. If universes can be born inside black holes, then maybe the rules of one cosmos shape the birth of the next. That would mean the DNA of our universe, its physical constants like the speed of light or the strength of forces, could be inherited traits from some parent universe. Imagine that, universes evolving like living creatures, with natural selection deciding which rules produce stable stars and galaxies. It's Darwinism, but on a scale so massive you'd need an imagination the size of infinity just to sketch it. Of course, the most unsettling part isn't just whether other universes exist, but what that means for us. If there are infinite universes, does that mean there are infinite versions of you? In one universe, maybe you're reading this script in another language. In another, you never existed because Earth never formed. In another yet, maybe you're a space pirate commuting between galaxies in a rocket-powered canoe. The thought is both liberating and terrifying. Infinity doesn't run out of room for possibilities, so everything that can exist might exist somewhere, and that means in some far-off universe, someone else might be dreaming about our universe, just as we're sitting here dreaming about theirs. It's almost impossible to hold in your head, but that's the paradoxical beauty of it. Infinity doesn't care if your brain feels overloaded. It just keeps stretching, stacking, and multiplying. And so the dream of other universes becomes not just a physics question, but almost a philosophical one. What does it mean to live in a universe if it's just one of countless others? Does it make us smaller, like tiny footnotes in an endless encyclopedia? Or does it make us grander because somehow, against the odds, we're here, thinking about it, writing about it, even joking about it? And maybe the strangest question of all is, if universes can dream each other into being, then who or what is dreaming us? Are we the imagination of a parent cosmos? Are we equations scribbled in some greater dimension? Or is dreaming simply the best word we've got for something our language isn't equipped to handle? Either way, standing here in our little corner of the multiverse, it feels like we're characters who suddenly realized the story might go on forever, each new chapter written inside the last. So next time you stare up at the stars, remember you might not just be looking into space. You might be peeking through the pages of a much bigger book, one where other universes are flipping past in ways we can't yet see. The dream doesn't stop with our cosmos. It spills outward, onward, endlessly. And the only thing stranger than dreaming about other universes is the possibility that they might be dreaming back. And just when you think the dream couldn't get any bigger, there's another twist waiting ahead. Because if other universes exist, we have to ask, how would we ever know? What kind of evidence could reach us across that cosmic divide? That mystery pulls us forward toward a horizon where science meets imagination and imagination stares right back.
Have you ever noticed how the biggest questions in life never really get solved? They just sort of curl up beside you like an old cat and keep you company. That's where we've arrived now, after wandering through black holes, wormholes, universes inside universes, infinities stacked like an endless cosmic tower of pancakes. And here you are, back in your own body, the simple weight of blankets pressing down, the familiar sound of your breath marking time. The room hasn't changed, the walls are still walls, but you've carried a whole cosmos back with you in your head. The mystery didn't go anywhere. It's right here, folded into the quiet rhythm of your pulse, waiting, like the ocean waiting to pull its waves back again. Think of it this way. You've just returned from the wildest expedition imaginable. No spaceship, no helmet, no snacks, just thought and imagination as your fuel. You've peered into black holes where even light itself couldn't escape, wondered if universes bloom inside them like secret gardens, floated among infinities too large to name.
and traced equations that seemed more like poetry than math. And yet here you are, tucked in, the same person who started this journey, only now you carry a secret, the realization that maybe you were never separate from it all in the first place. The cosmos doesn't just exist out there in the void. It beats inside you. Every atom in your body was forged in the collapse and fire of ancient stars. You are literally stitched out of starlight. When you think about it that way, going to bed is less about resting and more about slipping back into harmony with the universe's oldest lullaby. The unanswered questions don't nag, they soothe. What is infinity? What came before the Big Bang? Are black holes gateways or prisons? These are not puzzles you need to solve tonight. They're more like waves rolling in, steady and timeless. You can let them wash over you, because maybe the mystery is the point. Imagine if we had all the answers neatly filed away. Wouldn't the universe feel strangely smaller? Like a movie where someone spoiled the ending before you even bought your ticket? No, the vast unknown keeps the story alive. It keeps us curious, restless in the best way, awake even as we fall asleep. There's comfort in surrendering to what we don't know. You don't need to wrestle infinity into a box or force the multiverse to give you its secrets. It's enough to know you're part of it. You are a ripple in this endless fabric, a note in its symphony, a dream it's dreaming. When you close your eyes, the stars don't vanish. They hum softly in the background, like static on an old radio. The echoes of the universe's beginning still whispering through the dark. And in those whispers, there's a reminder. Even if your body is small compared to galaxies, your imagination stretches just as wide. So let the blankets feel heavy in the best way, like the gravity of a black hole holding you safe in orbit. Let your thoughts drift like comets wandering out beyond the edges of maps. Let yourself float into that twilight place, where wonder and sleep blur together. Because maybe the universe isn't asking you to figure it out right now. Maybe it's just inviting you to rest inside the mystery, to trust that being part of something infinite doesn't require you to solve it. It only asks that you live inside it, breathe inside it, dream inside it. And as you drift, think of this. The story isn't finished, not really. The universe is still unfolding, galaxies are still spinning, stars are still being born, and who knows, maybe somewhere another version of you is also lying down, also thinking about all of this, also smiling at the strangeness of it all. The mystery doesn't end with this chapter. It stretches onward, through space, through time, through dreams. So close your eyes, rest in it, and let the cosmos keep turning its pages. The night is vast, the story endless, and you, small, luminous, curious, are part of it forever.